Welcome back to the stream, folks. I don't have time for a super long one today, but we've got some parts freshly printed that I've been yearning to test. And then you see Tuco meowing in the background right on cue. Not sure what he wants, but I think he wants more breakfast, and he's had enough breakfast. Tuco, am I understanding you right? Are you asking for additional breakfast? Weird little animal. Anyway, welcome back. That's not what's supposed to be in frame. Dude. Cat is in cleaning mode. Well, I guess maybe it's a good time to get on with things. So here are the beautiful parts, mostly straight off the printer. I've already kind of compulsively started picking support material out of them. But this is the top half. This is the result of a lot of off-stream CAD work, and then many attempts at printing these and debugging some of the finer problems. There actually were a few reasons these prints kept failing. Some of the geometry that ended up sitting directly on the support material had some extreme overhangs that were and that ended up kind of bumping against the nozzle as they printed incorrectly. And so that was making the problem worse. There was a problem with the way I had mounted the filament spool that was dragging the x-axis a little bit. And then I still had to increase the current to the x-axis stepper drivers a couple of times. But after a stack of failed prints, I finally got these things. Yeah, SGDQ is pretty cool. If anybody doesn't know, it's a Games Done Quick. It's a video game speedrunning marathon that benefits work that tries to prevent cancer and work on cancer treatments. And yeah, it's really good stuff. It's really fun. You should be watching that also. So I certainly won't try to compete with that, but there's a reason people have a lot of pixels these days, right? It's okay if you watch my stream in super low resolution, so you have more bandwidth for the video game speedruns. I just wanted to stream these because these parts came off the printer and I want to try them out. Alright, and I've actually already tried these a little bit, and they actually are looking pretty alright. So this is what we're replacing. This is the previous version of the experiment with its very flimsy spool and little drive gear with Ninja Flex exterior and motor mount. And so this is the next revision of this. I've got to be careful not to burn myself on what's coming up next that's slightly out of frame. So then we've got these two pieces, which go together like that, and they fit. So it's the result of quite a lot of CAD work, since I ended up needing to basically design one piece that did all of the really heavy-duty structural work in this design. So this is responsible for mounting the spool of this winch that's moving around the robot we're designing. It also, so this is the main spool mount. It also has a similar mount for a roller. Whoops. A little hard to hold together and demonstrate at the same time, apparently. So then here's a mount for a big roller that the cord moves on next, and then we have two more rollers in this other axis, and then another roller, and all of that is just to kind of move the cord from the spool position up here for various reasons related to keeping the winch compact and keeping its center of gravity where I want it. I ended up moving around the cord like that. But then it gets the cord moving up here, directs it toward a set of sensors. So there's going to be a sensor here that measures the actual motion of the cord for the servo feedback, and then another sensor that's a load cell, so measuring the amount of force on the cord in this axis. And then we've got a feature for mounting the load cell amplifier. This is all part of the motor mount. These bolt holes are for mounting another bracket under here that I haven't designed yet that attaches some of the electronics and the side panels that go over this whole thing. And then this hole is for the wall mounting bracket, big ol' M8 threaded rod goes through there. So a lot of features I ended up having to design in this one piece, but that was in response to this previous design, which had a bunch of flaws, but worked well enough to where I thought, I can work with this design. Let's actually try to make it real. And I didn't really want to print another throwaway piece that was going to take like a couple days of printing, so then I went to the effort of doing a more thorough design for this thing. So I've already got this spool from last time. The side with the gear on it is a little bit warped because of a printing error, but it's still usable. It just looks a little wobbly. Besides, other than this one part like on the edge here somewhere that warped upwards, the rest of it seems pretty dimensionally accurate, so I think it'll do fine for a test at least. And it's much stronger than the last iteration. A lot more plastic in this one. And I've already got this roller assembled. I did this off camera because it was really simple. I can just take it apart really quick, but it's just a hollow tube that I printed just to get all the diameters right. This is M8 threaded rod. Oh, I was gonna put, this doesn't matter hugely, but it's a little bit tenuous with the tolerances between these nuts and the bearings to where there's barely enough clearance so that the nut doesn't scrape on the bearing shield, but it would be better if I had a spacer there, and I think I actually got some spacers, so maybe we can open some mail and have spacers. Oh, Tuco's on the rock again. Oh, you're a beautiful cat, little guy. I love you. I'm like, I've got bearing grease on some of my fingers, but I can pet him with the other fingers. So I got envelope. I think we're gonna find some speed washers in here, which are what the skating industry calls these spacers. I'm spacing out on who actually delivered this tip in the previous stream, but it was quite helpful. So yeah, 100 pack speed black washers. Speed washers, very strange. No, Tuco, that wasn't for you. That was because the trash can's far away. So we can try to add some of these just because we can. Those go between these outer nuts and the bearings. And so these are like skateboard bearings, 8mm diameter in the middle, 608 they're commonly called. And I based all the really big mechanical parts off of these 100mm 8mm shafts because that's what I had handy. They seem to be a good size and strength for what we're doing. They're actually, I think, a little bit longer than 100mm because they're sticking out a bit. And in the CAD model, they didn't stick out at all. But maybe something else ended up being a little shorter. I guess we'll find out. All right, so we got that. Now these I don't necessarily want them to be super tight. I mean, maybe I should have left, well, actually, it should be fine for these to be super tight, actually. I was thinking that if they were tight, they might transmit force to the bearing in a way that I don't actually want, but I think I'm overthinking that. Let's see if I can just torque this a little bit so it doesn't fall apart when it starts spinning quickly. So that seems fine. Not super cranked down, but I don't think that's going to wobble itself loose. Let's do something similar for this. Put some speed washers on our spool to make it speedier. Now, one thing that I noticed right away with these printed parts, which I'm hoping isn't a problem, but is something to keep an eye on, is that the bearing slots here are a little bit large, which is kind of intentional because before I was having some problems with the previous revision of this, which seemed to be due to the bearing mounts over constraining the shafts and causing it to bind a little bit. And so I wanted to give it some more clearance to avoid that. So some of the bearing mounts in this design, like this roller, I have to press the bearings into here because that friction is like all that's holding this roller on, so that has to be really tight. But then other stuff like here, I don't actually want the bearing mount to constrain it that much, so it kind of takes the opposite approach, but I'm worried I might have overdone it. So this time, this shaft is actually looking a little undersized, but I think we'll just, I think that was going to be the case. This had to be a little bit longer than 100 millimeters. So this doesn't quite fully engage, like this doesn't quite fill the nut entirely, but it engages with like 3/4 of the nut's threads, which is probably fine. I could back this nut off a little bit and then back the other one on some, balance them some more. That didn't do what I wanted. I need to actually push that through. Come on. Do I need a hammer again? That is not the angle to try to do this at. I don't know if I have a better way to do this that I can also get it on camera with. But is that my bumblefuck moment of the day? What is this actually seizing on? I think it's just really tight in here. I think the way I did this was to actually thread it on there. So maybe I just need to do that a little more. Let's use 2 of these nuts. Oh, that's good to know. James points out that once I have 3 threads engaged, I don't really get any more load-bearing capacity by engaging more threads. Well, then that's probably fine, but I feel like I kind of want to actually center this shaft a little better at this point. I think this just requires tightening these 2 nuts against each other a bit, and then, oh, which direction was I going here? I'm gonna put this on to see. So I think, yeah, I need to go that way a little bit. So I need to drive this in maybe 2 millimeters, at that, if that. Let's see if that's enough. That looks better. Let's leave it at that, and then put this on the other side, and then tighten it for reals. So this also means that if I can assemble it this way, then that problem where I needed an access hole to get to this nut is not as necessary, since I could just fully tighten this, then just slide it into these bearing recesses. But since I ended up finding a way to make this accessible without really messing up strength or print quality that much, I think it's probably good that we have that access recess anyway. That's just barely enough that with the motor mounted, I can get pliers in there to access that nut to tighten it when I need to. So maybe not as mandatory as I thought it was, but I'm still glad it's there. So then let's give this a good snug. How does that feel? Oh, that seems nice. Oh yeah, Nicholas asked if why I'm not using nylock nuts. Yeah, I thought about that. I might end up going with that. I just didn't have any handy. This is partly doing the right thing and partly doing the thing that's handy. But yeah, it would be easy to swap these out with nylon locking nuts. I've also got, like, I could put a little bit of thread lock on it, but that would be harder to disassemble. So, but yeah, I mean, right now I'm more interested in assembling this to get a test fit than for final assembly. So that takes care of the spool and this roller, which are the main pieces we have to insert with these two. I think I've already done most of the just little print cleanup, like taking off the support material and the brim. Oh, there's a little more support material to take out of this one. I think. Yeah. All these really deep holes need to be cleaned out still. There's this one for accessing the nut that holds the two halves together. And then there's this, which actually mounts the thing to the wall, so it's surrounded by plastic in an effort to make it strong. But I was careful to check out the G-code to make sure that this would end up giving me a lot of little support that I could remove like this. So I'm glad that worked out. Just push them all to the end and then scrape them out of this hole. There we go. So I could clean these up a little with the knife. I might do some of that because some of these edges right up against the build surface are a little gnarly. I mean, there's a lot of stuff that we could test fit. The thing I'm most interested in right now is the gearing mechanism. But as you can see, I ended up having to design a lot of features for this part to be complete. So like these holes I'm clearing out are for mounting the load cell that holds the main output kind of pulley. And a lot of this plastic here is not really necessary for mounting. I just ended up adding it to avoid having to print support material there. Like these two pieces. And so this is maybe bulked up a little more than it really needs to be. And it's kind of overly strong, but printing this solid turned out to be maybe more reliable than having to print something like this where I have a very large flat area that's all supported. My printer was having trouble with those, so I wanted to minimize them. This little thing over here is a channel for the wires. So I can have the wire for the optical encoder and the load cell sensor go downward, safely avoiding all the spinning parts, and then reach the actual electronics assembly on the bottom half of the thing. Cable management. And then these are holes for brass inserts so that I can mount the load cell amplifier. They're not going to be super strong, but it's enough for a circuit board mount. And this keeps the load cell amplifier close to the load cell, and I don't need to extend the wires for that circuit. Oh, here's another hole that just actually needs to be cleared out. Alright. This is approaching my definition of good enough for the current test. Oh, here's another bit of stuff to poke out. Mostly I got this angle by rotating, like there were a couple of reasons to rotate the model about 45 degrees relative to the printer's coordinate system. Having the support material offset from the angle of my model's natural lines is pretty nice. That should be mostly good. So, about ready to put these together. One complication is that I need to disassemble the old one, mostly to get the motor out of it. I don't have to get the motor out of it, but we're done with it, and I don't have that many of these motors, so I thought I would disassemble this now, and we might need to cut it apart since I had to hammer on this this gear onto the motor. So once we get to that part, we might end up using the hot knife to take that apart. Oh, Nicholas asked if there's a prior stream on the load cell. I've definitely used it on prior streams. I don't know if there's one that was really dedicated to it. It's actually on my list of things that I want to make a separate video about is the amplifier board, the HX711. I did have a video where I was talking about it a lot and we were experimenting with it. And yeah, it's an interesting little board and its protocol is a little bit weird. So there's something interesting to talk about maybe from just like a usage angle, but also from an implementation angle. Yeah, and I wasn't really sure how well the load cell would work. I included it in the design originally as kind of an experiment, but after trying it in the first revision, well, this one right over here, so it actually works quite well as far as I can tell. Like I haven't built a lot of facilities for really dealing with the data that much, but from what I can tell just from reading it off of logs screaming by on the terminal, it actually seems to be giving me a decent amount of resolution. So definitely kept it in the design, and I'm hoping that I can use it for maybe for some aspects of positioning, but also for like fault detection, so I can tell if something or somebody is tangled on the winch. Oh, Tuke, stay away from this. There's some hot stuff here, baby. Hey, Tuke. Alright, I think now I need to sneak in pliers. So now I have to hold that bolt with pliers. Since this version of it, the bearings are quite stuck in there, so I don't think I could easily just take it apart like this. Where are my smaller pliers? Oh, I need all those vice grips. This might be the right tool. Something like this, a little tighter. Yeah, and the load cell breakout board I got was like hardwired to only do the 10 sample per second update rate. But I think you can increase it to something like 40 samples per second or 60 samples or something like that. And so I rewired it to do that, and that was actually pretty nice too. It seemed like it was still giving me approximately useful data. All right, so the thermal disassembly might be to get the bearings out of these side mounts and to get the gear off the motor, because those are all in pretty tightly, and I'd rather destroy the plastic and save the bearings and other parts. So yeah, that's pressed in there really well. Oops. And then, how does this come apart? That's right, this shaft comes out first. And then that unsticks from the other gear. And so this doesn't have any parts I need. Then there's this whole thing, which is tricky. Because yeah, the motor is held on to this piece with bolts, and then this piece I actually had to hammer on to get it on there the first time. So I think I'm going to cut that out with the hot knife. Oh, and the nut is still hanging on there. Just force of grease and or magnets. Grease and magnets, the two forces that hold everything together. All right, let's get this over with. Let's try this piece first. Hot air gun and then pull them off. That might work, although I've got something ready already that might be faster. And ends up heating up the metal parts less. Tuco. Excuse the noise of the fan here. Tasty. Thank goodness for ventilation. Very. Delicious. So, there's that. And this one. Oh, Jarrett asks, is a hot knife basically soldering iron tip you don't care about? Or, in this case, it's a soldering iron made by Weller, sold at a craft store for about the same price as a cheap soldering iron was at Radio Shack at the time I got it. But the only difference really is that it comes with a couple of different tips, and in this case there's this wide flat tip that's actually kind of nice for this. But there's the model number. Yeah, it's a weird thing. But they make them for like wood burning and other craft things where you need a heat source. Cutting foam and stuff like that. But yeah, if you don't have one of these, you can certainly just use a soldering iron tip you don't care about. That just, if you've already used it for soldering, you might get contaminants in the plastic if you care about that, but usually in this case you won't. And it smells a little bit like printing PLA. Anyway, now I think I can just do something about this. So this one is a lot deeper, unfortunately. This might end up requiring multiple cuts and then pulling out chunks of it. Yeah, Tuco either wants more breakfast or he wants to go outside. And I don't really have the spoons to manage him being outside right at the moment, since I have plans where I have to go somewhere right after this, and if I have to like hunt down Tuco and figure out like, okay, where are you hanging out outside, then I'm probably overthinking it though. He really doesn't like it though when I have some reason for him not going outside that I can't really communicate. that cuts through the strong part of the 3D print and just leaves the weaker infill, which I'm hoping will make that easier to take apart, but mostly I need to get this gear off, and the problem is the gear is really thick and it's solid plastic. I'm trying to open up just a weak line along its radius. I think that's helping. I think I'm turning the gearbox. Yeah, I'm definitely turning the gearbox. Well, I can pull the tire off easily. That's no big win, but at least that opens up more room to get to the actual gear. I think I need multiple cuts. Let's maybe adjust the camera too. This is really just melting the plastic and trying to push it out of the way enough that it's no longer especially structural. And then maybe I can pull it apart when it's warm. The trick is just that this gear is really deep, and so getting all of the actually structural parts of it warm takes some effort. Get in there and push the parts apart. Barely, not really though. Trying not to overheat the plastic too much. Like, the ventilation here is pretty good, but I still want to limit the amount of toxic smoke I'm producing. Ah, yeah, nice. Motor rescued. I'm gonna turn off the heat, but leave the fan on for a bit. Okay, and now we just need a wrench to get the motor out of this. Oh yes, the dribbly remains of that little gear. This Nicholas in chat is recounting why this is why their product has thousands of screws. Yeah, in this case, I would have liked to use a screw to attach that to the shaft. That's actually how the previous version of this worked, but that was introducing a lot of wobble just due to how, you know, I made a couple of attempts at designing a set screw coupling, but they were all not especially concentric once the screw was tightened. So I think I could keep trying to tune that, but this time I tried a press fit and it was really easy to keep it concentric, but now the problem is disassembling it. I made the next version of this less tight, so hopefully I won't need a hammer to put this one together, but we'll see. Actually, I'll probably use a vise to put this one together. There's the melted together. This is still kind of warm. And here's that. Alright, and this is what's going on it. The slightly thicker side goes toward the motor, but I don't actually want to put this together until it's around the drive plate. So yeah, the motor goes on like that. These screws seem too long. Are we really using these? This is what? This is like M3 by 16? How do M3 by 10s compare to these holes that I've left myself? I could actually check the CAD model to see what I meant to use. But yeah, I think M3 by 10s are exactly right here. Oh, concentric flexures. Yeah, I already started to go into a deep thinking hole of thinking about how to design custom couplers for this, and then I ended up discarding a lot of that line of thinking and going back to gears, and that's how we ended up here. Well, maybe discarding is the wrong word. I still think that could work. I just started to think that gears would be easier. We can have some more quiet here. Yeah, this PLA stays hot for a while when you get a big glob of it warm, so that can be not fun if you get it on you. Okay, I should be careful that these screws are as tight as I'm going to want them to be, because getting access to these again is not really going to happen once I've got that gear on. I think this is plenty. And okay, so how tight is this? I was really trying not to accidentally put it on until I had this in place, because that would have been difficult to get back off, but now I can actually try to put it on. I'm going to take a quick pass at cleaning the brim off of this with a knife. Well, actually I didn't even print this with a brim, and usually there's a little bit of a flare on the edge where it prints right up against the build plate, but I don't really see much of one, so maybe the printer was dialed in enough to avoid that. So I think this is still going to need the hammer to go on. And so I'm probably going to hammer it most of the way on, and then check the alignment really carefully as I get close to set the Z alignment. Can I at least get this started on the desk, or I'm going to have to go to a sturdier surface right away? That desk is just absorbing like all of the hammer blow. Concrete floor it is. Let's see if I can get this started at least. If you hot air the hole through and then slide it on, will that actually keep it warm enough? I guess we could try that. That's an interesting idea. Hot air through the hole. This is just barely on at the moment. It's a little wobbly, but the herringbone is straight. That's what matters. Okay, let's try Mikkel's suggestion. That seems pretty nice. Hot air through the hole, then put it on. Did I already get it stuck on there? I have anything that can grab this effectively. Yeah, maybe we're going ahead with the hammer at this point. I think, let's check the fit. Oh, this is going to be much easier if I don't put the shaft together until after the gears are meshed, isn't it? Or can I just force this in by squishing the gears? Because the gears are a little flexy. Oh yeah, that works. I can just push it together. Okay, cool. So I don't have to disassemble that. I can, but I don't have to. And there's plenty more for that to move. So let's gently hammer it. Or preheat the shaft. Yeah. It does seem like that would have been another way to do this. Let's check that again. Still way too up, but good to be checking this. That's seeming pretty nice so far, though. You could also sharpen the shaft. Yeah. I don't think that was helping. I was trying to get that under the gearbox so that I wouldn't be resting the gear or the motor at such a weird angle. I think I need a piece of scrap wood or something better than a box of drill buttons. Also open some more ventilation. Everything is happening so far below where things usually happen here. That felt like it moved significantly. Let's try that. Oh, still more. But we're getting close. Still more. Yeah, it's really hard to see how much of the D shaft I have left. Ew, that might be good. I think we might have a mesh here. Let's put the other side on. Yeah. Let's maybe put this together. I want to see this thing turn. Okay, so let's also put in this roller while we're at it. And then we need 2 shafts to actually hold the 2 halves of the frame together. Alright, so this one's also ready to go. That one sits in there. Those fit together. Yay. That's a little loose, but we can put some glue in if it needs to be tighter, I guess. Let's see how it is once we put these in. Ooh, yeah. Oh, yeah. That's right. This end and that end. Loosen the nut on this side a little bit and keep it tight on that side. This piece would be a little easier to assemble with bolts than with threaded shafts. These are just what I had handy. So I'm tightening this nut and then fitting it into this little locking area and then tightening the other side. Yeah, cool. I need to do the same thing on the other side. And this doesn't have to be amazingly tight, but that should hold together pretty nicely. Let's try this side. This time. Oh, see here, it would actually be nice to just drive the shaft directly without this nut. It'd be nice if I had room to put 2 nuts on there, but I kind of don't. So I'm just going to try grabbing this with pliers and trying to be nice to the threads to tighten this into the nut. That on. Come on. Yeah. Great. Now we've got those both tightened. So that and that are tight, and that are tight. So we've got a roller, we've got a spool. Eventually some stuff is going to go on top of here. We actually needed to mount that before putting it together, but we can save that part. Let's just see if the gears work. So, let's get the power supply ready. All right, we're about to get a look at how well these new gears work. Wow, I can backdrive this worm gear through it. That's probably not great for the worm gearbox, but all right. So this motor is rated for 24 volts. I'm just going to be running it really slowly so we can watch the gears mesh. And I might even try lubricating the gears while they're moving, while the motor is moving pretty slowly. So let's just do like 3 volts. And oh yeah. I'm pretty happy with that. Let's add a little bit of lubrication and then try cranking up the speed. Find that lube I had nearby. Yeah. This is the stuff I wanted to try. It's PTFE lubrication. So I'm hoping it'll stay slippery in these conditions and not deteriorate the plastics. I'm going to just put a glove on and smear it on with my finger. So the gears in this case are made from Semiflex, which is a blend of thermoplastic urethane and PLA. And then the rest of this is just PLA, and like the things that are obviously metal are metal, but then most of it's 3D printed. So, and then my goal with the flexible gears here was to reduce noise, and so far I think I'm pretty happy with how that's working out. Because the noise from this metal gearbox is easily louder than anything I'm hearing from the plastic parts. Make sure this is sufficiently gooped up so I can, because I'm going to want to lubricate this for actually running it, so might as well actually test it with lubrication on too. Smear it in a few places and then see how well it spreads. Oops, let's not get it on the spool if I can avoid it. Hey Tuco, was that you? Of course it was him. Cat probably just wants to play or wants additional breakfast. Ooh, sticky. Oh, now I made my gears loud, thanks. Huh. Okay, well maybe let's just mop up the extra lube that comes off here. Or maybe, maybe there's not enough, and that is the noise of it kind of, the boundary between the lube and the air happening. All right, let's add a little more. What could go wrong? Tuco, you want to play right now, don't you? That just seems to be sinking to the bottom of this whole assembly. I'm just trying to apply it a little more evenly, but maybe I'm just digging myself a bigger hole here. Anyway, maybe I'll stop trying to lubricate this and we can just test to see how well it runs at higher speed. Yeah, now if I run it faster, it's just going to spray this lube everywhere. Okay, well maybe I choose a different lube next time. Hey, Tuco. Oh, Tuco really wants to play. Great, now it sounds like I'm making popcorn. And Tuco wants to play. Oh, this is only 8 volts. Let me ditch this lube-covered glove and then turn up the voltage. Well, that lube was a fail as far as quietness is concerned. It's not the worst noise, but it's pretty weird. Now there's like lube dripping from way over here. All right. That's 24 volts, a little over actually. I'm pretty happy with that. Yeah, I mean, you don't necessarily need to lubricate plastic gears, but it certainly helps. I've heard this lubrication work pretty well for PLA, but I've never heard it tried on semi-flex, so I guess now I know. But yeah, I'm pretty happy with this assembly. I might end up having to change to a different kind of lube, which could be messy. I'll have to clean this off, but that's pretty nice. Yeah, Robert reminds us to use lube that does not degrade the plastic, which is certainly important. Yeah, some common petroleum lubes can certainly mess up plastics. Well, my first attempt, I think, is just going to be to remove most of this lube and see if it quiets up when I just have very little of this. Because I don't think it takes much of this to be slippery. I have like almost none of it on my hand now, and my hand is super slippery. Okay, cool. Can we try actually using these rollers maybe? Let's actually turn the power supply off. So, we've got this main thing, we've got this little roller, we've got mounts for 2 more little rollers, which I need to assemble. So we've got, this was actually a previous attempt that I was disassembling to get the bearings out of. That. Bearing. This is just like an outer cylinder and an inner cylinder stacked together. The hot knife is already cold, or it would just be really convenient for this too. There we go. And over here I have the new versions, which will look almost identical to the old versions, but these are the rollers that go in here, fresh off the printer. Oh, okay. Mikkel says that looks like PTFE and silicon. Yeah, exactly. And I looked at the tube, but yeah, I mean, I got this specifically because people were recommending that it's inert against plastics. It's silicone and PTFE. But I wasn't expecting it to be loud. But as James is pointing out, it might quiet down once the extra lube has been squeezed away to the side. So yeah, I think I'll stick with it and just I won't mess with the lube too much, and I'll see if it quiets on its own. And if not, I'll try something more complicated. At the moment, oh, 2-coke gets on my nerves so much. Let's try out these rollers, and I don't have super much more time to stream, but I was hoping we could at least get this set up so that it can reel in and unreel some nylon cord so that we can watch it do what it's supposed to. I think, yeah, these are M6 by, oh geez, this is one that I tried Loctiting. Where's my bin of those that aren't stuck together? M6 by 20? 40. Oh, 30? Yeah, M6 by 30. That's what I had a bunch of. Need some nuts that go along with these, though. Chico. Meow. What a cat. Okay, so the way these go together, there's an inner piece, which I just stuck in there because it was convenient. These actually printed separately. There's a inner sleeve that goes between the two bearings, and then an outer sleeve that goes around the two bearings. It's just kind of a way to have a roller that didn't take up a lot of room to its sides. So the mount in this had to be pretty small. That's like support material that I should just be able to cut out. I've been calling these little 3D printer defects where the printer nozzle kind of dribbles a little extra plastic. I've been calling them boogers, and someone in my YouTube comments pointed out that in the UK those are called bogies. I think those are both appropriate names for these 3D printing objects. These are going to be a tighter fit. I might have to use my little vise to press this one together. A lot of these defects are kind of a location on each layer where the printer ended up moving up to the next layer or switching to a different part of the print, and so it just leaves just like a tiny extra bit of plastic there, and then the perimeter is no longer smooth, which I think might matter given how tight these are going to be fitting. Probably could have just left a little more room for that in the model. So then this also needs to be able to go around a bolt. That's fine. I also want to trim off any extra stuff on the edges here that could get stuck when it's inside. Oh yeah, Mikkel points out that I don't actually need those little stops in it, so I could avoid the support. Yeah, that's true. I also liked the opportunity to make the walls of the cylinder a little thicker for strength, but maybe that was over-engineering it. Oh, this is really annoying. I think I might want to use a different tool to trim this. Tuco, I think I know what you want, buddy, but now's not a good time. I think that amount is fine. So then, oh geez, this is the one that I cleaned out. So, bearing, then roller. Yeah, that's gonna need some pressing action. And then inner thingy, and then bearing. So I think that whole stack up of stuff goes into my little vise, and we hope it's all good. Oh, Tuco really wants my attention. Tuco, I see you. I just don't know what you want. Well, in the context of what I can do right now, I think he wants to go outside, which is not something that I want to do right now. But communication. I'm hoping everything is sized properly for this to spin freely. Yeah, can't I just tell Tuco he has to be home in 30 minutes? Yeah, seriously. Oh, it feels like the bearing is maybe not the smoothest thing, but this will do. So then I think the middle piece has to be lined up a little better. Roller. All right, now is it possible to mount that? Also, I'm gonna have lube all over my hands. This is terrible. So each of these, there are going to be 2 of these rollers, and the roller snaps in between these 2 pillars, and then the bolt goes in from this side. Let's try the bolt first. This is kind of a weird contraption that actually holds most of the force here. Like you can see there's basically a little plastic washer on each side, and there's room for a nut on this side, and I can tighten the whole thing from there. But I'm really supporting the whole load of this roller by the body of the nut and the head of the bolt here. So it's kind of a weird shape. So I think first thing, I try to put this in. So far, so good. And then need an M6 nut and the corresponding screwdriver. All right. Oh, my hands are so slippery. So then that fits in there. And then I line this up. far so good. It's torquing down nicely. And then, oh, that's, not as smooth as I'd like it to be. Why not? Is it maybe those plastic bumps are actually touching the shield of the bearings? Is it that same problem before? This might be a problem. Might need to look closer at this in a little bit. Let's try backing off that screw just a little bit and see how it feels. Oh, that's a lot better actually. Maybe I can put some washers in there. I'm thinking that maybe the problem is that those little bumps are too wide at the very tip. Maybe I can just trim them a little bit with a knife. Like maybe there's actually a little bump there, like another bogey ruining my day. That's close though. I might be able to run some cord through this in a sec. Yeah, actually, I'm gonna fuss with this in a sec, but let me just keep this assembled, and I wanna try running some nylon cord through this. We don't actually need both of the rollers for that. Oh, I keep touching the gear. Okay. Ah. I had a little piece that I was using for these experiments, but then I took that and cut it into pieces for my induction swing. So let's get some fresh paracord off the roller here. So it's a lot easier to put through here if I cut it first. Just through that little hole. Oh, actually, let's do this. Let's run it through both of these rollers. Sorry, through this roller, and then onto. So I can actually just use that and have it lift something from the ground if I wanted to. So then this can go through here, and then this ties off. And I will probably eventually make a new version of this centerpiece that has a recess for the knot, but at the moment it just deals with the knot by keeping it near the edge, and then the spool winds pretty evenly over it still. At least it did in the last version. So let's try slowly winding this up and see if we can get some good behavior out of it. Less voltage though, 3 volts. And as for direction, I mean, this will kind of work in either direction, but it's really designed for the spool to wind up, I guess, counterclockwise, the way we'd be looking at it here. So that's unwinding. Let's change the polarity. Get more favorable exposure here without this. there's our winch winding very slowly. And these rollers are not doing an amazing job of rolling, but I think this little one is a little off-center. Like there's a bit of wobble around the bolt, so it's just kind of finding the narrowest spot instead of actually rolling. The plastic is pretty smooth though. It's still not very much friction. So let's increase the voltage. This is 13 volts. This is coming right off of a larger spool of paracord, and it's kind of getting a little twisted. This is part of why I wanted to make the spool a little oversized, so I don't have to worry too much about the packing being completely perfect. I can just give it room to pack a little bit randomly as it winds. Mikkel says try increasing the load on the cord. Yeah, I probably should have been doing that for this entire run. We can do that on the next run. I'll try. I don't necessarily want an entirely enormous pile of cord here. Let's try unrolling it a bit. But if you look at how that wound, that actually was reasonably centered. Like not perfect, but I think it'll be good enough. The actual test I want to do with this, which we're really close to being able to do, is to take a decent length of cord like this, have a fully assembled winch prototype, and then take a weight and just run it up and down a whole bunch and make sure that the cord doesn't get tangled while it does that for a while. So this is cool. I'm gonna have to wrap this up pretty soon, but so far I'm really liking this design, and I think I'm liking this enough that it might be worth going ahead and getting the printers going on making another copy of these. I do need some other pieces, like the piece that attaches here, and there's a piece that attaches up here that I don't have designed yet, but until I have those designed, maybe just printing a couple more of these would be the thing to do. Or printing more spools. I don't know. We might still find problems in the design that require rework, but stuff like this, I just need to reprint this single piece, which is like a 30-minute print on the little printer. So let's try running it in the other direction a bit. So I'm gonna have to remember that if you run the motor in the polarity it's marked, that's actually unspooling the cord. See, now the rollers sometimes run. That front roller is gone. I'm not actually putting much load on this roller. I would be if I was drawing the cord actually around the top the way it's designed to go. Yeah, see that little jump that you just saw was the cord wrapping in a way that changed angles pretty drastically. And I'm hoping to avoid those by keeping the load on the cord fairly constant as it's being wound. But if I do get those, then the control loop on each winch bot will at least compensate for that in how it drives the motor. So here it is unwound. Now I'm going to try winding it again once this hits pretty close to the end with more of a load on it. So that's near the end of the winch. I'm just going to swap these wires and put more load on it as it winds. Of course my hands are covered in lube now. Yeah, part of, as Mikkel's already explaining in chat, but just to make it clear for folks who are just listening, there are a lot of opportunities for the cord to wind in strange ways or like slip on the winch roller, but what I'm trying to do is to compensate for a lot of that with closed loop control by actually monitoring how far the cord is actually moving near the actual output of the winch bot. You can see I just let a little curl make its way all the way onto the spool, which is not good. Whoa. That's not going to end well. Let's cut the power. Yeah, so you won't be feeding knots into this in actual operation, and there's also going to be a set of rollers here that kind of straighten out the cord, and then while it's straight, press it against a capstan with an encoder on it so we can measure how far it's moving. And then the final pulley in the winch bot is actually going to be mounted on a load cell so we can get some idea of the force on just the external part of the cord. And that'll be a good warning sign, like, oh, something's wrong, you better kill the power and let a human take a look at what's going on. And so, yeah, the actual winch firmware is going to take in messages that say, I want the cord at the encoder to move at this speed, and then the winch will have a little PID loop that maintains that. But the commands coming in from the central controller will also have upper and lower bounds for the load cell readings. So if there's more or less force on the cord than we're expecting, then we can have the algorithm in the winch like stop and wait for something else to tell it what to do. So that's another fail-safe procedure. Let's just unwind this a little bit and then roll it. And then probably end the stream because I gotta go to lunch. Cal says, maybe a semi-flex sleeve with a slightly undersized groove in it around the rollers to grab the cord. So these rollers, I don't care about them grabbing the cord. The reason the bearings exist is to reduce friction, so there's no reason for me to be adding friction to that system. If these rollers are not turning, it just means that the friction on the plastic is already lower than what the bearings are providing, which means I should be making the bearings better. But on the measurement capstan, where I do actually care about it moving at the same rate as the cord, I'm doing two things to help ensure that. I'm actually pushing it against the capstan using the roller next to it is applying a little bit of a push. I'm converting some of the cord's tension into force against the roller. And then I also have some little bumps in that capstan to try to help grab the cord. And that one's made of PLA and not semi-flex. I probably could make that a semi-flex. I wonder if that would help. That squeaking sound is my hand moving against the cord because of the lube. This will be a better test once I can just put a weight on this instead of trying to apply resistance manually, because this is not a perfect process. Oops, and I almost bled a knot through, but I don't think I quite did. Gotta be actively untangling this here, and I'm still not putting much load on it. Yeah, so I'm doing a terrible job of being consistent here, and it's still doing a good enough job of winding. Okay, that's enough. Okay, I think that was a pretty successful test for today, and I think the gears are quieter, if that's not just me. I'm trying to wipe off some of the excess lube. Ugh. It was like spraying lube onto the outside of the spool here, but the design, I was planning on having lubrication here the entire time, and the way this is designed, it should at least keep the lube off of the nylon rope, which would be nice. That was not a good strategy for keeping it off my fingers. Yeah, Mikkel points out, don't have it too flexible since the diameter of the capstan needs to be well known. Yeah, that's true. I don't think I need to do much with the capstan design, though. This is actually my current design, which I copied a lot of this over to the new design without really changing it. Can I get this angled a little better? So, yeah. So this was the original wider idler, as I was calling it, which was doing the job of kind of centering the cord here. That's been replaced by these two rollers. Well, the third and the fourth, this system of rollers. But then between this idler and this idler, so if you draw a line directly between these, it kind of cuts into this capstan a little bit. So you can imagine if this is a cord under tension and I'm kind of bringing the capstan into it, you can imagine the cord's going to want to push back using some fraction of its tension based on how that angle is set. So that's how I'm coupling this. And then I've just got a set screw, and you can see I'm having a little trouble with the set screw coupling here too. It's a little wobbly, but I think that's going to be fine. The diameter is still pretty constant, even if the angle is a little off. And then this is just an off-the-shelf encoder. It's pretty high res. I think it's 600 counts per revolution. And then just an idler on the end of a strain gauge. This was the original strain gauge mount. That gets mounted over here. Oh, the motor is a little bit warm. Just barely, though. And that was getting more of a workout than it's usually going to be while it's hauling the camera around. Since I don't expect it to be moving that much or that quickly. On average, just in bursts. Well, I hope that was interesting. I certainly enjoyed taking a look at some of these parts that finally finished printing. And it looks like we've got a green light to go ahead with the rest of this. So next time I have a chance to stream some work on this, I'll be assembling the rest of this, putting these rollers in the top, getting the sensors mounted, and we'll get to actually try running some software on this thing and doing some longer term tests to see if the cord gets tangled. Mikkel says the 4-winch bot should have a tug-of-war, load limited, of course. I mean, that's basically what's going to be happening when they're lifting this robot. Because, you know, the 4 of them, the higher the robot goes in the space, the more it's going to look like the 4 winches are just pulling against each other, like anchored in the center of the room. So that is one reason that geometrically it's quite nice to have high ceilings for installing a robot like this. Otherwise, if you're running really close to the height of your pulleys, then it is kind of like a tug-of-war, and you end up needing a lot of power just to fight the other robots. So, oh yeah, and we didn't really try it out, but there's also a wall mount for this, so might as well put that in. I mean, I haven't designed the wall mount bracket yet, but this is the place where that'll eventually go. Is not small enough to not spin on its own, but there's that. I'm still not entirely sure how the mounting is going to work, but that should at least hold enough weight with it anchored into something else. So the idea is to support it with this back surface and this under tension, and then this will be pulling up against that to some extent. All right. I think that's all I got. Hey Tuco, you gonna finish the show for me? Happy hacking, everyone. I hope you can have as peaceful a time in your life at some moment as this cat experiences day to day. He's certainly my inspiration. I hope he can inspire some of you too. Even as he's licking himself. All right, hope everyone has a good day. Happy hacking. And car alarms during the post-roll.